Okay, so we have this idea that there is a certain amount in this reaction, a certain amount of, I guess, heat that will either be released or taken in.
Because H is enthalpy.
Exactly, delta H means enthalpy.
And I guess the F means final.
Almost. In this case, when we're dealing with delta H with the little f, little subscript f, that means formation. So it's this idea that with this reaction, and I'm actually going to write it down just so I can have it up here on the board.
Okay.
PBO solid plus CO solid.
No, CO gas.
Oh, gas. Gas makes PB solid CO2 gas.
Yes.
Solid CO2 gas.
And the enthalpy is a negative 131.
For the whole, is it for the whole reaction? Oh yeah. Because I just had to make sure I knew what I was asking, because I was like, what is it trying to do? Is it trying to help us find the... Because it's, okay, I understand everything about it now. Negative 131. Okay. Kilojoules. So.
And then these are the amounts for these two, which comes up with a chart.
Yes, that comes from a chart. Okay, so enthalpy. First off, what is enthalpy? Can you tell me what that is? What's the first thing you think of? Maybe you think of something. Just try to connect anything with this delta H.
I don't know. I just know how to, I mean, like, I know how to find it. If, you know, like if you add, like you're trying to if you're trying to find the enthalpy of this, and they give you some other reactions,
Yes.
then you could see how to work it in there and add their enthalpies together to get the final enthalpy.
Yes.
So I guess I don't know how to explain it. I know what to do with it.
Okay,
That's what I need
okay.
to learn, is to be able to learn how to say what it is. Maybe that'll help me on the
Well,
test.
how about this? Enthalpy is this idea that there is within a system, within something, you know, within this marker per se, or within this reaction, that there is a certain amount of total energy that it contains. So enthalpy
Is that
is
energy
simply
plus work, heat plus work, or is that?
yeah.
Or is that?
You're talking about this equation, energy equaling Q plus delta V,
Yeah.
like that, right?
Yeah.
Yes, you remember that from chapter 11?
Mm-hmm.
Yes. So energy being, in this case, heat plus work. Yeah. So this particular reaction has some sort of energy associated with it. This you won't necessarily be applying to this.
Okay.
I actually am not sure if there is a way that they apply. I never learned anything like that.
Okay.
So don't necessarily worry about connecting those. The main thing is knowing that delta H symbolizes the change in energy of this whatever you're dealing with.
Oh, okay.
So
the ability to
HP
exchange heat at a constant pressure.
Okay, yes. So a lot of times, because we're dealing with reactions just in constant pressure, in other words, we're not in a scenario where pressure is constantly changing. It's just pressure's the same. Like in this room, the pressure is just the same. If we did a reaction on this table, then how we can determine enthalpy will simply be by how much heat it comes off of it.
Okay, so why I thought that the energy, because I have this little, right here, it says the delta H equals delta E plus
Oh,
P
well that's
delta
nice.
V.
Good.
But I
Delta H equals delta E plus P delta V, which I actually am glad you shared that. So it's this idea that enthalpy then is equal to energy, and perhaps it even is this when we're dealing with this. These connect somehow, right? You can see how there's change in energy of the system plus the amount of pressure times the change in volume it's doing. That'll be its total enthalpy. So you see how energy is associated with heat and work, which actually would be, this would be work. So we have heat and work. So if, like, let's say I had a balloon and I blow it up, so it changes energy, or not changes energy, it gets bigger.
Yeah.
So potentially, it's actually doing energy, it's doing
It's expanding.
work on the air around it. It's pushing it away. So then, if we had a reaction, let's say, and let's pretend it's like a balloon where it expands, kind of like a gas, and so it expands and gets bigger, but at the same time releases energy. And by the way, this is just helping you know definitions of
and I
enthalpy.
do appreciate that.
Yes. Then there would be a change of volume associated with it, and let's say heat was released as well. So then we could say the enthalpy that this reaction kind of expressed, or what made up the energy of the system in terms of what we just saw when we made the reaction happen. We saw that it changed in volume and it also released heat. So those two factors are what makes up enthalpy. At least
Okay.
two of them that I don't know if it's more complicated than this, but this is just,
Camera 6 level.
yeah, this helps us. I don't even know really more. So just remember that enthalpy equals total energy. So you can almost think of both of these together
Okay.
as being like the total energy of a system.
Okay.
So, system. So, but if we're at constant pressure, which I'm actually guessing would be, like if the volume changed and stuff like that, I'm not exactly sure 100% how that would all affect. But at constant pressure, we can simply just say that the delta H of a system is equal to the amount of heat either it takes in or lets out. So that's why we can always look at it this way and say, oh, delta H just means heat.
Okay.
Khan Academy has a really good explanation on this too if you look at it online on YouTube.
On
Just look up
enthalpy.
enthalpy, Khan Academy, or just enthalpy on YouTube. You'll find some good stuff that will really explain this. You don't have to necessarily understand how it all correlates, but it does help to understand at least definitions.
Okay.
So, in this particular case, we have been given for this reaction the delta H equaling negative 131.4 kilojoules. So now, what do you think that means then?
That's how much was sent or released, spent or released?
Okay, good. So we're saying that there was some sort of energy as this reaction took place that was released. What gave you the idea that it was released?
I think because it was taught to me.
Because it was taught to
Yeah.
you. Well, then what
the
is
negative,
the
yeah.
negative sign,
Yeah.
right? So when we're referring to enthalpy and we say negative, we're saying that for this particular system, or we're saying the reaction itself, so the reactants turning to products, it lost heat.
So it's exothermic?
It's exothermic. So we use a negative number to show that. It's almost like if I had $100 and I gave $50 away, on your bank account, if you look online, it'll say $100. It'll say, I can't think of the word.
Deficit, not
Right,
deficit.
it'll show that, and it'll be a negative 50 from your 100, right?
Yeah, yeah.
You lost $50. So it's the same with this. This had a certain amount of energy, but it lost in the process of reacting this much.
Yeah,
So that's telling us for this whole reaction.
yeah.
What we are trying to find is this. The question is saying, at this, where is that
Number
question?
4.
Oh, number
Sorry.
4. It's saying, okay, using this information below, calculate the delta H of formation for PbO solid. So it wants us to find the delta H of formation of Pb, lead oxide.
Yeah, so the very first reactant.
Yes. So it's saying, okay, well, what is the delta H of F, which means formation of lead oxide, which is saying, okay, well, each of these, and we can even boil it down to this. So we talked about this being the total enthalpy of this whole reaction.
Mhm.
But each of these have their own delta H's, per se.
Yeah.
They have their own amount of energy that they contribute to the overall reaction, which gave us this in a total, but individually they have their own enthalpies. So we can know what their enthalpies are. Well,
So for that
I
one, we have
guess
a-
that
for
comes
one,
from
we
a
have
chart.
question mark, so it'd be like, okay, go ahead.
Good, yes, so question mark, boom. So these, we get these values from a chart. They're either given to us because other scientists have
Yeah.
done all the work for us to
Only
find
two
out
of
what
us
they are.
have them. We're only given two values
We're only given two values.
for CO2 and CO.
We have this and this. Okay, so we have this number for, so let's write that down. So we have the delta H of formation for CO, right, which
Yeah.
is what?
Carbon, that's not carbon dioxide, is it?
No, this is carbon monoxide.
Carbon monoxide, yeah. Okay, and that's a negative 110.5 kilojoules.
Good.
And then the carbon dioxide.
And then the carbon dioxide.
Yeah,